Back again with part 2, where we're going to go over the stereo version of the tube PreAmp modeling. Now I'm not going to go over the parameters, obviously I already did that in the first video. Instead I'm going to compare this to some other tube plugins to show that this thing is kind of a chameleon of distortion. It's definitely the most versatile distortion unit in the Kronos, capable of subtle saturation to extreme sound mangling capabilities. So this first one to compare with is by Audifx, and it's the Summing Tube Amplifier series. This is a master of subtlety, and I throw it on everything. It just brightens up whatever you put through it. To start off with, I have a drum loop, and then let's enable this thing. So you can hear a huge difference. Dry, wet. And then let's turn it off again and compare this drum loop dry to wet with the stereo tube. Bypassed and wet. So you can hear we have very similar results. And to also compare those results, let's look at a sine wave. Bypassed, just plain sine wave. And then with the summing tube amplifier, we see a very subtle harmonic. Bypassing that again and throwing on our stereo tube from the Kronos. And we again see subtle harmonics. Not too much crazy saturation going on, just a touch of brightness. So let's move on to the next one, which is the UAD 610B. And let me unbypass that and bypass the stereo. So here's how this sounds. Tons of harmonics from this thing. You can see all this motion going on and this kind of characteristic notching going on. Those were just some simple 2-note chords. So let's bypass this and then check out our stereo tube. And this time I'm going to boost up the gain. So that's with not a lot of saturation. And let's compensate for our output level. You can see that again, we do get a ton of harmonics. With the characteristic notching. And then bypassing that and going back again to the 610B. So this thing can do the subtlety of this plugin, but then it can also do the extremes of this plugin. So again, the versatility is pretty incredible with this. Now I want to talk a bit about soft clipping and loudness and mastering. So if we have a sine wave, we are hearing its volume based on its peak amplitude. But what if we have a square wave with the same exact peak amplitude? So let's check what the sine wave is at. We're at minus 18.2. I'm going to switch over to a square wave where I already matched the volume. So we're actually peaking less at minus 18.5. But notice how much louder that square wave sounds. If you think about the physics of what the diaphragm is doing when it's producing a square wave versus a sine wave, the velocity of the diaphragm is less intense with a sine wave, which is nice and smooth, than it is with square wave, which is making the diaphragm fly forward and fly backwards. In other words, the diaphragm is moving faster over the same distance than when it plays back a sine wave. It's moving a bit more slowly back and forth. The frequency of that motion is the same for both waveforms, but the velocity is different. So the square wave sounds louder because of that. It has to do with air displacement. There's stronger compression and rarefaction, more intense compression and rarefaction going on in the air from the square wave than there is with the smooth sine wave. So when we're mastering, we can use this to make mixes louder. Now, let me show you a sine wave again. And I can add odd harmonics to that sine wave by turning on my stereo tube preamp modeler. I've effectively increased the velocity of the diaphragm with this shape. It's now a bit louder, and you can hear it, and you can even see the added spectral content that adds to its volume. So same peak, but different perceived loudness. Now, if a waveform has asymmetry, so this sine wave has symmetry, a square wave has symmetry, but something that has that's asymmetrical, that's horizontally asymmetrical, that is different across the axis, like a sawtooth wave, that is not as efficient as far as producing loudness between its peak volume and what we perceive. So if you think about it in terms of how much area on this graph is covered from this shaped sine wave versus a sawtooth wave, I actually should have pulled up a sawtooth wave for this example, but the sawtooth wave won't cover as much area. And if you think of it in terms of like that, can you think of a waveform that would cover as much area as possible? I mean, it's pretty obvious. Noise. Whereas you would only cover technically 2 quadrants from any waveform, from any given waveform, noise, by virtue of covering all 4 quadrants, produces the loudest sound, covers the most area in this graph. At any given moment, this will be louder than any waveform. So that's one reason why, one explanation why noise is the loudest thing you can possibly hear. But yeah, so let's apply what we now know to drums. So I have a drum loop. I'm going to go ahead and play it dry. And then I'll turn on my my tube preamp. Let's see. There we go. I'll turn on my tube preamp and let's see how the volume changes from adding just a bit of odd harmonics. First, let's see where we're peaking. We're at minus 11.2. Let's turn this on. So notice that jump in volume. Again, let me bypass it. Pretty drastic change in volume, just from adding a few odd order harmonics. And we're still peaking at about the same volume. Like, let me reset the meter here. We're probably even saving headroom just from adding the odd harmonics. So it looks like we're peaking at around minus 11.5, 11.4. Now remember, bias creates asymmetry in the waveform. It adds even order harmonics, essentially making the sound less efficient with its headroom. So what happens if we add bias to this signal right now? Let's try it out. So again, we're at minus 11.4. Turning bias all the way up with this light saturation doesn't really do much for us except steal headroom. So if you want to use the stereo tube preamp modeling insert effect as a soft clipper mastering tool to maximize the amount of volume you're getting out of your mix, you're always going to want to leave bias off because you don't want that asymmetrical distortion. You don't want to limit the amount of area you're covering. And yeah, I think you get it. I think you understand this breakdown. The last thing I want to show off is a nice little trick with the phase. So let me go back to a square wave. Why not? Let's go with a square wave. And I'm actually going to reduce the output since the square wave is so loud. And I'm already adding some distortion right now. But what I want to show off is if we flip the phase of the incoming signal and then put our dry wet on 50-50. Technically, anything that's the same will then cancel out between our dry and our wet signal. So let's look at what this looks like. I'll leave bias on because I actually want to add even harmonics. I want to distort this thing in a particular way. Let me turn this off. See all those even harmonics go away. Now they're back. Let's flip this phase. Wet invert and put the dry wet on 50-50. Let's hear what this sounds like. Wow. So since the square wave is predominantly odd harmonics, I've effectively had it cancel a lot of the distortion that was produced. But I think all we're doing is really lowering the odd harmonics at this point. The odd harmonics are getting canceled, phase canceled. But the even order harmonics, those that are being added by the distortion, should technically stay the same. I mean, yeah, they technically should. Let's put it on all the way wet. About the same, roughly the same. So we see a much greater dip in volume from the odd order harmonics than we do the even. Let me show you the same thing with a sine wave. I think with a sine wave, it'll better illustrate what I'm trying to show off here. So here's a sine wave dry, sine wave wet, sine wave on 50-50. Again, we've lowered the sound of our fundamental. So if you essentially have the wet inverted, then you are canceling out the original waveform and you're kind of left with just what's being produced by the saturation unit or by the stereo tube preamp modeling. I want to do this also with listening to the drums because I haven't tried that out yet. I want to see what that sounds like. Wow. So again, we've canceled out our original signal. And we're essentially left with everything that we're adding via distortion. So it even works on full mixes. Really helps you dial in what's happening with the distortion unit. Technically, if I were to low pass this, then I would be gaining back, I guess, a bit of the original dry sound. You can hear that snare, sounds nice and clear. Let's try it with the kick. Now the kick is normal. Wow, I love it. But we're still saturating, of course, the snare and everything. Let's give it even more. Cool. Yeah, wow. This is a very sophisticated plugin. Tons of things you could do with this. It's really neat. Yeah, so that's it for this one. Hopefully it was, some parts were semi-interesting. And I'll see you when I'm going over the mic modeler. Right.